Okay, before we convert the scene over to a spherical scene or use planetary terrains, I want to show you how you can create your own infinite terrain presets from any functions you created. So we're going to go to the terrain editor, so edit the terrain object. Now, one thing you can do is just modify any of the presets by going to the altitude production and right-click Edit Function on the Procedural preview. You can also go into the Function Output Observer, open that up in order to preview the terrain. So you can make any changes to the terrain fractal or creating a combination of fractals, adding different links to the chain on the way to the output. Now, going back to what I had mentioned earlier about the material being incorrect, if you go to the second output, Detect Rough Areas, this is a reference feature size that is being outputted by a custom output or a custom dependency. Right-click, Add Output, Custom Dependency, and you can link this to any of the available functions. In this case, the rough area output. So just by dragging that handle, you can select the altitude or the rough area, and then that is called upon within the material editor. So that second output, rough area, is set to 13. 1.3 would probably be a little better since the changes to the numeric value have changed. So once you've made any changes, what you can do is go down to the lower right and you can save and save yourself a preset. So I'm going to go ahead and click OK and just show you really quick how the material is calling on that part of the function. What we have is a mixed material, so two different materials with basically an alpha type distribution. That alpha is that detect rough areas or the reference feature output. So we right-click, edit the function, the distribution, and we can see we have an external dependency. So you can right-click, add input node, external dependency. You can then select the terrain, which is the brown, and that's called smooth detect, was that one that is connected to the second output, and that custom dependency I left in there unconnected is also available. So you can rename them, see them when they're available. One thing I like to do to separate my custom dependencies is before the title I usually put a left and right bracket and then name it. Now it doesn't really matter at this point because it's not going to get seen, but that way it does separate that from the built-in outputs. So this has a filter on it, and we only really see a very small amount of the output. Reset the filter, and the output is actually only from 0 to 1 rather than being from negative 1 to 1. So we're going to kind of clamp that down. And what I'm also going to do is add in a filter, change this over to the map, set our lower value for the output negative 1, and take the upper value and set that to 0. Actually, we'll go ahead and use 0.1 because we're extending beyond 1. So this way we'll have a much better distribution based on that output. You could also choose to just delete that other filter and instead change the lower value and upper value to match the terrain. So we could do 0 for the lower and 1 for the upper value, but now we're still kind of back where we were before. So now we can make the upper value 2, or let's go ahead and use 0.6. actually, because we need to only use that very minimum value to produce and stretch out to the larger value. It's not really going to stretch or reduce any of the quality because it is a procedural. So this controls the distribution between these two materials. I also want to note, if you go to the options, you can change the preview if you want that to be a terrain. So now you can see a terrain preview. You can also change if you want to get rid of that checker pattern in the background. And if you want a larger material preview, you can open up the zoom panel. And this can be resized. You can click render, and it'll render out the material. Now the scale of this is not definable. So in this case we have an infinite terrain, and the scales need to be set rather large without having too much detail to overload the scene or cause too much flickering. So it is a good idea to do a few test renders to see the material better, at least with this large of an object. The smooth blending strip is an additional modifier of the distribution of material 1 and 2, that sort of alpha that mixes them. So you can sort of create more of a gradient or a harsher cutoff with the smooth blending strip. Because there's a built-in threshold for the most part. So we'll go ahead and we can smooth that out just a little to open up the range instead of constraining it. And a quick note about materials while I'm at it. If you're having any problems with flickering, and go ahead and look at the function. There's currently no bump set to possibly either of these. Go ahead and take a look. Within all the fractal nodes, there's what's called a smallest feature. I'll go ahead and add in a fractal node from the left, and we can take a look. The smallest feature option allows you to adjust, well, there's the smallest feature, so whatever is going to be the smallest amount. So if we set this to 1, our smallest feature should, depending on the wavelength, different settings, it'd be around 1 meter would be the smallest. So for the procedural terrain, for any sort of bumps or anything that's going to react with the highlight, it's a good idea to turn up that smallest feature option for animation, because most of the time those small details aren't needed and they're just going to cause problems. An additional way to create an infinite procedural terrain is to convert a regular procedural terrain over to an infinite. So what we can do is select, I'm going to add in a new procedural terrain. And we can edit the object. And turn off zero edges, which would get basically turned off anyway. And up at the top, you can change this and convert it over to a standard terrain. So taking the procedural information and turning it into a polygonal object and the height field terrain. You can also select infinite. That will convert it over. It'll also let you know if there are multiple infinite terrains and whether or not you want to replace it. I'm going to select no. Now, once you've changed that, you basically lose the ability to turn off infinite. That's just something that's been around ever since infinite terrains are. Once you convert it over to an infinite terrain, it's basically unavailable for export, and you can't use it like a regular terrain. It will extend to the end of the scene always. So once you make that conversion, you can save it out. It'll also save out any materials, and that way you can customize your own terrains, load them in, and create your own presets. So let's go ahead and change this scene over now and take a look at the Spherical Scene option. We're going to go to the Options panel, and under Scene Options, we have Spherical Scene, We can also choose whether or not to show the sea in renders at this point. So basically that's just hiding it from the render, that sea level object. Whether or not we want to see the object in the views, I'm not sure that's going to apply too much within Xtreme. And then also we can adjust the altitude up or down. So I'm going to turn on Spherical Scene, and it's going to let you know that the aerial perspective will be reset to 1. Now the reason for this is because it is calculating what would be a realistic or Earth-like aerial perspective based on the size of the scene radius being what would be basically the size of the planet. And we also have the option to move the native objects onto the surface. So now we're converting this over to a spherical scene. And probably going to need to go to that infinite terrain and modify, at least first going to edit the object to get a refresh. Click OK. Just after opening it, and that'll refresh the terrain. So now the scene is set up to be spherical. And that is a rather interesting looking object floating in the sky, which is the sea level object. We're going to have to do the same thing we did before with the terrain, and that is to edit the object and click OK. Just to update the proxy, since it did distort it a rather large amount. And that's because it is set to the displaced water surface, which I do believe I did have that turned off. So I am going to edit the object, turn off displaced water surface. I do not want to have that extra geometry. I don't need it. And we're going to go to that other procedural terrain I created in negative key keyboard, minus key, and just clear it from the scene. Now, it is hard to see, but the terrain is a little more curvy. At least it appears to somewhat be. Whether or not it's actually reflected within the OpenGL, we'll have to see once we render it. I think for the best really kind of idea of how this is working would be to decrease the scale of the scene so we can see the curvature a little bit better. So we're going to go to the options and change scene options and reduce the scene radius. Let's bring it down to 500 kilometers. And we'll go ahead and exaggerate it a little bit more. Let's do 50 kilometers, just for fun. And I'm going to edit the object. Click OK. And there's a possibility that it's really just not going to show. But it does look like there is a lot more curvature now, because we do have the terrain on the right side where we can see the bounding box touching that bottom portion, and then towards the center it is lifting up. So it is just very subtle at this point and difficult to see, but in fact the terrain is curved. Now if we go over to the atmosphere editor, go to the Sky, Fog, and Haze tab, we'll be able to see that the aerial perspective is set to 1 grayed out. So adjusting the atmospheric thickness is now automatically defined by the size of the scene and the distance from the terrain. So go to the camera, and we're going to lift it up. And let's raise it up to 15 kilometers. And we'll do a render. Remembering it is an infinite terrain, so we really don't have to worry too much about having the proxies in view. And we'll tilt it down just a little bit. Okay, so the curvature is really something that's just not going to show in the Lightwave OpenGL. If we take a look, we can see the extent of the terrain. We can also see where the sunlight's coming in and the shadows being cast onto the haze, which is much further above the surface than would be realistic. But that's another thing that adjusts the atmospheric density, is adjusting the overall sky height and then also the haze. So right now my sky mean altitude is 4 kilometers. Let's go ahead and switch this over to perspective view and go to our options, scene options, and turn on use planetary terrains. So now we have planetary terrain scene. And it looks like this probably will not be showing the correct display either. So this is more than likely something you'd want to do within the standalone version until future updates allow that to show the actual curvature. So that's definitely an option. And another one of the features where it's going to be best to really be working with it within the standalone, because otherwise this is just going to be way too difficult to really judge anything. Now placing the objects, we can place the Lightwave objects on this surface and they will be bent around with the terrain because the place native object option, if you turn it off, then they will stay as part of that grid, but the object and terrain itself will be spherical. So setting up the scene would probably be best in the standalone, and then opening that scene within Xtreme. So I'm going to go ahead back to the options, go to the scene options, and turn off the spherical scene. We're going to go back to the other version we had. And go to our camera view. And go ahead and drop down the camera. And let's go ahead and take a look at our position. So we're at 1.5 kilometers. We're going to go ahead and set this to 2 kilometers. And open up the atmosphere editor. And go to the cloud tab. And we're going to add in one of the cloud presets. Let's start with the dark cumulus. Now, this is also another feature that can be a little bit easier to modify within the standalone because you do get a preview within the OpenGL of where the clouds are. But you can still modify them pretty easily. Just pay attention to the units in the scene where the camera's at. If you want to be above the clouds, just make sure that the altitude, we're going to go ahead and bring this down to 800 meters, and then set the height to, let's go ahead and use 400 meters. And take a look at a render. Now, the cloud presets are one of those features that were severely impacted by the transition and change of the internal unit in View 8. Version 7 users will find this a little more friendly with the internal unit or view unit set to 0.1 because of the way the scales are set up. And it has to do with the slider ranges and the scales of the materials. So right now, this cloud layer is massively huge, or at least the procedural and the function that is creating it. I like the height of it and the altitude, which are fairly accurate for the most part. But if we go to the atmosphere editor and take a look at the range, I mean, look, the slider for the altitude 800 is below the normal range, and we can raise it all the way up to 100 kilometers, which just doesn't really make any sense because the troposphere ends from to about 10 to 14 kilometers, which is the area of the atmosphere in which weather is and where we have clouds. So we wouldn't need it to go beyond 10, and even most of these types of clouds, cumulus and these other show-type clouds that View is really good at creating, most of those don't even appear all that high. This is an atmospheric reference I created to show where most cloud types exist. And this curvature of the tropopause, which is basically where the troposphere ends. And if you ever take a look at cumulonimbus clouds, really large storm clouds, and up at the top they start to change shape and spread out, that's because they're extending above the tropopause. Now, it changes because the Earth is, of course, squashed a little, and what is causing that, and that's that force, is also extruding the atmosphere to around 14 kilometers at the equator and around 10 at the poles. So that it does change depending on where you are on the Earth. But most weather in the types of clouds that View is really good at, cumulus and stratus and the like, really don't go beyond 4 kilometers. Most of that weather is between 0 and 2 kilometers. Of course, that can depend on your area above sea level. So if you're up in the mountains, you would be a lot higher above sea level. So you will be able to have other types of clouds. So here are also some reference of some more common mountain ranges to show exactly how that lines up with the overall atmosphere. So this is also included with the training, so you can use this reference if you want. It's kind of nice to fall back on for creating realistic skies. So by having the internal unit set to 1, or the view unit set to 1 meter, it does extend the range of all these sliders and change all the presets to be ridiculously unrealistic. Within the sky fog and haze, the same thing happens, where the sky mean altitude, and this is the mean altitude, not necessarily the total extent of the sky, but where the sky starts to fall off into darker ranges, going up to 100 kilometers, which, considering when we changed it over to planetary scenes, the area of perspective being changed to 1 automatically. It does make it a little difficult to modify some of these settings. So really the best thing to do is reduce our scales of our functions. So these are the overall controls. And then we have a detail amount, which starts to go into this function. We have the cloud layer detail, and adjusting the detail amount will decide how much of these settings are used. And then the overall shape of the clouds is the density production. So to kind of give you an idea, this would be with no detail, rendered no detail of the clouds, so just the noise. So typically you start with a noise node or a very basic fractal to generate the overall shape, and then you use the detail to subtract from that and create more realistic looking clouds. So this would be just that noise. This would be, once you start adding the detail, we can start to get the shape of the cloud, and then you can adjust the scaling and the roughness in order to really pull out away from that noise. New features that were added as of version 7 were the ability to feather the clouds, so this is with feathering, and then the sharpness option, which is the contrast. So this is without feathers, but with detail. So you can really see those defined lines. And version 8 and 7.5 have a huge improvement over the quality of the cloud renders. And these were created in very early versions of View 7, just before the release. So I'm going to go ahead and change back the altitude. And actually, I'll go ahead and bring it to 600 meters for the altitude and change the height to 1 kilometer. We'll make them a little bigger. The cover is the fill range, kind of like adjusting the filter. So taking the white areas of the function and extending them to fill in more of the clouds. And density, opacity, and sharpness are more of the shading of the cloud, along with the ambient lighting. And then the shadow density, if we go to edit the material, go to the lighting and effects, if you have cast shadows turned on, the clouds will cast shadows on the scene. So on your light wave objects, on the view terrains, view objects. You can also set up the internal shadows, GI ambient lighting, and you can force the ambient light colors. So one thing you can do is set the ambient light color to black, and then change under the color and density the volumetric color to a much darker color and create storm clouds. And it looks like the terrain is once again missing. So go back, edit the object, click OK, and refresh the proxy. And take a look at the new cloud settings. And I did just go ahead and change my altitude to 800 and my height to 250 meters because otherwise it was taking a really long time to render because the camera was in the cloud layer. Whenever the camera is in the cloud layer, it's going to take much longer to render than when you're outside of that volume. Even if the clouds aren't in front of the camera and very far away, if you're within that space and that volume, it does tend to take a little bit longer to render. So that definitely looks a lot better. I did use a different reconstruction filter, soft mode, so everything is a little blurred. This would be a little better for animation rather than a still. But we can see a lot more detail from the fractal and something a little bit closer to what the original preset was intended. So just bumping over the decimal point to the left did work a lot better. You can also see the changes I made to the distribution of the material within the procedural terrain. A lot more color variation now and distribution between those materials, so that does also look better. Now, I'm going to go ahead and save this scene. I'll call it Infinite Terrain with Clouds. And lose our Infinite Terrain proxy again. Hopefully, that will get fixed, because I am currently using version 8.4. 0.4 versions are typically the last of the updates for the version you own and the current license. Now that 8.5 is out, I'm not sure if regular good old version 8 will be receiving any more updates. We'll have to see. As of version 7.5, if we go to the Atmosphere Editor, go to the Sky, Fog, and Haze tab, we do have the ability to project shadows onto the clouds. So using projected shadows on clouds will allow you to have the terrains project shadows onto clouds. This is a much better option than the previous volumetric sunlight, which took a lot longer to render. When you're using spherical planetary scenes, the landscape and the curvature also casts a shadow on those cloud layers. And this is a render showing that shadow projection on a cloud layer. So this is one cloud layer, and you can see the shadows moving throughout away from the sun, and the layers casting shadows on other layers as well. So if you had multiple layers, and actually, now I'm looking at, I think this actually might have been 2 cloud layers. So then, as you layer clouds on top of each other, they will cast shadows onto each other. It does increase render time a little. So I also want to note, when you're adding additional cloud layers, that they do not have a set layering except for the way the altitude is set. Whichever cloud layer has the highest altitude will be on top, and the layers with the lowest altitude will be on the bottom. So if I take the altitude of the dark cumulus and change it up to 100K, that becomes the top of the list. You can turn the eye on and off to disable or enable your cloud layers from the render. Also, if you want to adjust the lighting on clouds, you can adjust the cloud scattering underneath the glow intensity and scattering. And the more you reduce the amount, the more of a diffused look you will get. This is a render I created with the scattering option for the clouds turned up a little higher. And that way I was able to create a more intense glow around the back of the clouds. And this scene is 3 cloud layers, one in the back, and then more fog-like lower cloud layer that with very minimal density. And then there's kind of a medium cloud layer creating some darker clouds in between. And I also forgot there is a very high altitude cloud layer as well. And these are casting shadows on each other, so you can get some really nice results. And a lot of these lighting tweaks for the clouds sometimes better be done in a standalone, just because you get a faster response with the render preview.